And we're waiting for the challenge. Oh, here it comes. Here comes the challenge. Let's turn up the music as well. You're going back home after a hard working day, and a fundamental question is asked to you. What can I eat tonight? Oh yeah, well, that's a good question. Excuse me. Don't forget the, what? You're tired to open your fridge every evening and asking the same question, so you decide to create a program which will give you all possible recipes you can cook with the foods you have. An integer for the number of you have in your fridge. Next 10 lines store corresponding string corresponding to the names of the different foods you have in your fridge. Next line, an integer for the number of recipes that you know. P next line strings where the first input corresponds to the name of the recipe and the next input corresponds to the foods needed to cook the recipe. X lines, strings corresponding to cookable recipes with no recipes can be cooked. Just write fast food joker. Output recipes given in the same order they've been reading in the standards input. Excuse me. Fastest? That's those are comma separated, so that'll be an interesting remembrance. There we go. Okay, so what do we got here? This is the number of ingredients, available food, so we need to store those in a vector. And a string, a vector of strings, and let's just say available. There we go. And then as we get available food, we'll just go available pushback available food. Okay. And then as we go through the recipes, what we want to do is parse out the comma separated. So what we want is an iString stream of, actually let's do it inside. So with each recipe we want an iString stream ISS of the recipe. Excuse me. And then while, do we use get line? And then isn't it input stream, so it's going to be ISS, the buffer to store into, so we need a string token. And then we need a delimiter, which is the comma. Okay, while that, so that'll put the recipe in token. What we want is a vector of strings. Excuse me, we're going to go ingredients. So what we'll do is just ing.pushback token. So now what we'll do is we will cycle through the available food, right here. So for each recipe, for int I equals 1, I is less than ing.size, I plus plus. And then we're going to go like this, can make equals false, or no, equals true. And then if, so this recipe, ingredients, if ingredients sub I is in, how do we know if it's in another vector? Do we have to just cycle through the vector? Let's see if there's a way. The find algorithm, okay. Contains da-da-da. In this function, we iterate over each string in vector 2 and use find to check that it exists in vector 1. If find does not find the string, it returns an error pointing to vector end. If we find any string that is also in vector, return true. Finish loop finding in common strings, return false. This function will tell you any strings of vec2 are in vec1. If you want to check all strings of vec2 are in vec1, you probably modify them. Okay. So find begin end and then the string. Okay. Make sure it's not the vector end. Okay, so and find is vector string algorithm, vector string algorithm. Okay, we have that. If find std find, excuse me. And we're looking in the vector of well, the first vector is available, isn't it? Yeah, avail. So avail dot begin, comma avail dot end. We're looking for ingredient sub I. Is not equal to avail dot end. So if it's not equal to avail dot end, then can make will still be true. Let's go like that. Then we'll just go can make equals false. And then we'll just break out of the loop, actually, at that point. I believe, so just break. ing.size. So that will go through that one recipe, ignoring the first one, okay? And then after that, we'll go if can make, then cout ing sub 0. Excuse me, else cout, or we won't, no, go like that. And then we want to count the number of recipes. So we're going to go int r equals 0. So then right here we're going to actually do more than that. So we're going to go like this. And then we'll go r plus plus. So the number of recipes. And then after we're done cycling through all the recipes, then we go if r equals 0. Excuse me, was that from my throat? What is it? Junk food joker? Fast food joker. Alright, let's see what we get. Oh, it's working. Nice. Oh, very nice. I like that find. That works really well. Okay, cool. Holy Lord. Quiche au salmon. Yep, took me 9 minutes, took him 9 minutes, took him 2 minutes in Ruby. Oh, cool. Wow. Alright, play again. I'm just in the mood to do clashes today. I'm going to walk around for a little bit while that works. Ugh. Let's have 2 minutes of... Beep. There. I should trim those up a little bit more. Like those D&D images. We're gonna trim those up, I think, because I don't want the edges to show. We can trim up the edges here in a bit. 6 seconds. So where is the shaders for those? Where are the shaders for those? Pardon me. Player lasers, spaceship, background, super shape, textured points. No, textured points, procedure, asteroids, no. Where is it? Is it, super shape, new text, space cube, probably here? Flowers, crystal, D&D stuff, okay. So where's this? Space Planets 115 FFS, open. Cleanup. Space Planets 115 FS, okay. Let's go to the challenge, fastest mode. You'll be given a list of numbers as input, and you should sort the positions of only the even numbers in the list in ascending order. Do I have to do something to use the sort function? I don't think so. So we can just go what dot begin, what dot end. Okay, what does it say again? You'll be given a list of numbers as input. You should sort the positions of only the even numbers in the list. Oh. How would we do that? Let's see. So let's go like that. Then we'll just sort the even ones. Then we'll cycle through again for int I equals 0. I is less than what dot length? I plus plus, or size, excuse me, size. Okay, we need to keep track of the E index. And then we just want to go what sub I equals even sub E. And then we also need to increment E at that point. Here. Print the sorted list. Pardon me. There we go. So all I did was sort the evens and then go back through and replace any even with this sorted. And then printed the whole thing because I really don't even need to do this. Because we can just go if what I mod 2, just see out even E instead of what, and then, but yeah, but we did it this way. But we did it that way. Okay, so let's look at this. Now what is the, decide if drawing lines or points. Is line equals 1, just draw the color. Points now branch based on type. Flower, crystal, D&D tax. Okay, so D&D tax right here. Grid type, divide by 95. Oh, here's the size right here. Want to go the other way? See what that does. Just play around. Okay, we're still getting the square shapes. So is the square shape actually a part of the texture? It's been so long since I've used this texture, but is it this one? No, it's not that one. It's this one. Okay, the square shape is a part of some of the textures. See, like these, which kind of drives me crazy, but it's fine. Let's just look. It looks like it's all the same color. Oh, interesting. So let's mask out like those colors. Let's find out what colors those are, just to have a little bit of fun. How do we zoom in? Zoom in. See, like this? Oops. Okay. So dropper, give me that color. And that's just, oh, pretty solid. 196, okay. Dropper, is that the same color as that? Edit colors, 196, okay. And then what colors are here? Oh, okay. So we can just take out any, hold on. So let's go like this. Or that. Okay, good. So we're just going to filter out any gray whatsoever of any shade. Okay, that works. I think that works. There's some really cool... We can also close it in just slightly. See, like right here. GL point chord. Oh yeah. Oh wait, that's the beginning. That's GL point chord times that plus vector XY. That's the size right there. Actually, we can just subtract it up here, or we can go. Hey, dude did it with Python. Nice. Okay, that's what I was thinking, yeah. Okay, perfect. Okay, cool. So inner point chord, this is all we need. And we'll just change that. So let's go here. Whoa, computer, what are you doing? Crazy. There we go. So now we're just going in all around the texture. Looks like it might not be enough. That was 5%. Let's go twice that. So we'll just sample the inner 90%. See, it's not showing like that. That's bizarre. Let's make it a little bit more obvious. So only the inner 50%. It's actually zooming it out. Okay. Yeah, that looks more obvious, doesn't it? Okay. So at least I know I'm doing the right thing that way. Let's just go 10%. Or let's go 80 and then 0.1. There. See if that looks better. Alright, those are really cool. Did we get a... What we got here? Oh, it's just finished. Okay, so let's see if these people dropped out or what. What are you doing? Dropping out? Clashing? What? Clashing. Computer? Belly cat. And they did drop out. Okay, fine. Crazy. Crazy people. People crazy. Okay, so that is cool. So what I'm thinking I want to do... Also, is it rendering them upside down? Hold on. Is it rendering them upside down? So what if I go negative y? Or 1 minus y or something? Or isn't it when we load that space? Because is it upside down? Let me see. Space planets. Where is it? Points textures. This one. Oh, we don't do that. Why don't we do that? Flip vertically on load. Set it to true. Are they upside right now? I can't really tell. Were they upside right before? Really no clue. Bum, 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 bum. Looks like they're still upside down. I don't know. Also, when we're doing this in the init data or whatever, Oh, but we want more than that. How many do we have on the texture? $60, $80, and then minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, minus 41. 6,039. Oh, now it's getting all of them. There we go. Okay. Cool. Okay, so also on the asteroids, playing around a little more here. On the asteroids, these are texture ship parts. Where did I put it? Atlas texture, no, super shapes, coordinate spheres. Oh, here. BK asteroids 01. So what's the texture that we load here? Final 3. Yeah, we got the people at the bottom here. So these little peeps, yeah. Okay, so right here. That's it. That's what we can do. So when we choose down here and one of them becomes -1, we can choose from the last how many rows and how many of the characters are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32 times 6 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 32 times 6 plus 10. 202. All right. Oops, I just forgot it. 32 times 6 plus 10, 202. Okay. So let's choose a random number of negative. Let's just say negative 1 to 202. That's a little more readable. So now it's a negative 202. So there's nothing really going to change just yet. Because it's okay, it's just checking to see if it's greater than negative 1. Oh, although it could be 0. Negative 1, okay. And then subtract 1. So it goes from 0 to negative 201, subtract 1, so then it goes from negative 1 to negative 202. There, now there won't be a problem. And then in the shader, what we would do is, see? Okay, so for now we're going to fill them all in so the asteroids will have little guys where they're, so it'll be perfect squares. But let's do it like this. Float x equals the fractional part of true type divided by 32. Okay, and then float y equals the floor of true type divided by 32 divided by 36. So true type though, we need to start from the maximum of the other ones. Now, where's the maximum? D&D type? Wait, is the whole thing 32 by 36? I forget. Oh no, those 36. So is this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Yeah. So 32 by 36, right? Okay. So 36. So we want to start 36, 35, 34, 33, 32, 31. We want to start on line 30. So x So in the shader, the type is negative, -1 to 202. So true type so in this case we actually start true type, or we can actually just to the y we'll just add 30. So we'll just go 30.0 plus. And then x we don't have to do anything. You actually subtract 1 because the first one will be 0. So then we'll just go. And then when we do this with true type, we need the absolute value of true type here. True type. In this one, we need the absolute value of true type -1. And same here, -1. Or +1, sorry, +1. Because it starts at -1, we're going to want it to start at 0. And then we'll add 30 to the y, go like that, and then down here, then we got x and y, and then we'll go this part. We need this and that. What's the t-mult? Oh, okay, whatever. So then we'll go x2, y2, text color 2, ftext, what's that? Oh, that's the actual, okay. That's the in, okay. And then xy, x2, y2, excuse me. Why is it changing it to gray? Why doesn't it just discard? I think with the guys we want them to discard. Here, let's comment that out, and then right here let's put a discard. Otherwise, go forward and do that, yeah. See if this works. And then if it does work, what we're going to do is just randomly choose one of the empty spots and put a little guy there. We're not going to fill all the empty spots. Uh-oh. Now we've got major lag going on. What's going on? I don't see the asteroids. And it's not changing. Oh wait, there it is. What in the world's going on? Why did it do that? Oh, because tmult is not in there. That's not an error, but maybe that was causing some issues? No, there's something else. And it's not rendering the asteroids at all. Uh-oh. I've broken it. Well, in the meantime, let's just do this. Let's make them all blue. So we'll just fill in the empty spots with blue for now. Okay, so it is doing that. Oh, and those look kind of cool. So let's see what was causing the trouble. Let's just go like this. I don't think it's that, but let's see. Just calculate the value. Oh, it's the calculation right there. So it's one of those calculations. Fractional part of the absolute value of true type plus 1. Oh, true type is not in scope either. That's the problem. So does that solve the problem, or did I save it? Okay, so that was the problem and now we fixed it. So let's go back. So we want to use this one. There we go. Okay. Oh, so, but we're getting, oh, random textures. That's cool, but not the ones I'm looking for. Those aren't the droids I'm looking for. So now it's filling it in with a random. For now, let's select. Instead of wow, 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 wow. So 30 plus that. True type plus 1 divided by 32. So let's make that a float anyways. Float TT1 equals absolute value of true type plus 1 divided by 32. Then we can just replace this with the fractional part of 2t1 and replace this with the floor of TT1. Save a calculation, I guess. But then why is it not showing the little guys? Why is it showing 30 plus that? See, why is the floor of TT1 fractional part? It is showing the textures. I'm not sure. Let's go look at it again. Like, what are some of the textures that it's showing? Just the other textures, right? Oh wait, we need to add 30 divided by 36 because that's going to be a portion of 36. That's why. And it was looping around possibly? Yeah, there we go. Now it's all the little guys. Actually, that looks really cute. But you can't actually see what they look like, but it's still cute. So now it's got all the random the little guys there. That's hilarious, Jeff. I know. I know. It's funny. So now let's just choose. So what we're going to do when we do the initialization here is here we will have a, see here, it's going to go, it's looping inside of this, inside of that. Okay. Okay, so what we'll do is we will go like this. If random3 equals 0, so within each one of these, we'll do another random like this. If random mod 15 equals 0, or mod 5. No, 15, because I don't know. Then we'll do this. Let's just put it in brackets, just so I know that it happens. Okay. Otherwise, we want this. Oh, we have to have a way to draw nothing, just the discard. So let's go. If f type is greater than negative 210, then do this. Okay, otherwise, then discard. Okay, so then we'll just go into here, and then we'll just go equal to negative 210 right here. So now we'll have some, mostly empty spots, and then we'll have some little guys on the thing. Yeah, see, we have just sporadic little guys. It's not one per yet, but... Oh, because what we do... Let's go like this. And one chosen. Okay, then we'll reset. We'll just go one chosen equals true. So we'll only choose one per block at most. And we'll put random 5 as the opportunity there. So basically after we choose one, we're turning it off. So there's only one per. One little guy per asteroid at most. Actually, yeah, we can just increase the odds there just a bit. Actually, let's just go with the first blank one. So we'll just go with not chosen, one chosen. So that'll just go with the first empty one that it sets, and then the rest of them will not have a little guy. So everyone will have one now, definitely. Okay. Yeah, see, everyone has one. Wait, does that one have one? Have you got one? Have you got one? There's your little guy. Some of them don't. Is it because they're too small to render? Like that one looks like it's super small. It might be the dark ones or whatever. Some of them are dark and not that visible. Like these purple ones that are really dark, and that one, and some of these other ones. Okay. Alright, so otherwise we're good. That was fun. It's kind of fun. Fastest mode, Clash now. Okay. I think I missed that one. Let's go into Twitch. Have we got anyone watching? Oh, okay. Alright. Since not, we will just end. Thank you very much.